just a show of hands, quick show of hands, who's seen How to Train Your Dragon? Which is good. Great. All right. So our adventure is pretty much like that. Like, I thought that was a cool title, but it actually makes sense for us because microservices were a completely foreign thing at DreamWorks. There was no services to speak of. So to come in there and say these are great things, the village was a little resistant to it. So our story is pretty much convincing the village it's not so bad. So who am I? So I'm Doug Sherman. I'm a principal engineer over at DreamWorks. I've been there for about 8 years now. For about 20 years, I've been in this kind of crazy domain in the entertainment space. I've worked at visual effects companies, at Warner Brothers, at Disney, and some of these other places, and it's all the same kind of crazy culture there, which I love. Some people hate it. I love it. It runs a little chaotic, but a lot of creative people, and lately we get to do a lot of really creative things in this space, which has been kind of fun. So a little bit about DreamWorks to give you kind of a background as to how microservices would have made sense there at all. They're an entertainment company that's trying to compete with the big dogs. They're out there trying to go after the Pixars. They want to just keep pushing that edge, and they want their stuff to look cool, and that comes at a cost. So give you a little bit of kind of numbers that are interesting there. Every year we try to do at least 2 or 3 movies, releases, and that's going against all the other releases out there, including the Marvel movies. It's a lot of kids' films out there, but they want to compete, so they want to get a lot of stuff out there. These things cost hundreds of millions of dollars to produce and to advertise and everything else, so they're not cheap. They're big bets. We have hundreds of global markets. They're all different, their likes, their tastes. It's amazing which one country will like, another country won't like as much, but they all contribute to the bottom end, so it's all important that they get out there. There's at any given time, because of different stages of production, 7 things going on. Different productions, whether they're even now TV related with Netflix and major productions. And we have 3 worldwide studios. We have one in Glendale, near the Los Angeles area. We have one out in India, and we have one actually now out in China. So it makes life interesting. So these are our cast of characters, the more notable ones at least. The one on the furthest end, Trolls, that one's coming out, I think, another 3 months or so. And it's actually looking pretty good. It's kind of fun. We get to see kind of the dailies, and we watch these things progress. It's always ruined for me by the time I get to go see it. I've seen it 1,000 times, but for everyone else, it should be pretty good. So, like I said before, this company is all about pushing the edge. So the complexity, as much as I got a little bit of resistance on the infrastructure side, definitely not on the effects side and on the character detail side. They go for it. And every production, it's the more and more complicated character. And again, it's all to sell, look how cool this stuff looks and look how awesome this is. And that does sell. There is a certain sheen to it. The reason I'm there, I love the quality. I love the look. So I can take you guys through like a really quick Animation 101 class, again, to get you guys kind of acclimated to where I exist. So Kung Fu Panda 3 is the last release, so I'll kind of reference it from that. This is just one shot. It's kind of a flat image, so it doesn't look like a lot's going on there. It looks like someone could have painted that, but there's actually a lot of detail and a lot of process that went into making that single image. So any given character goes through stages, little rough sketches, gets a little more complicated, and they add more embellishment on there. And this goes for every character. And there's principal characters, there's minor characters, there's crowd characters. There's a whole lot of dimensions. And then there's background elements. You got all these little bits and pieces back there, and then it's not enough. They got to add more. And so each one of these things, if you pulled it out of the scene, they're complicated in their own right. They've got their own texturing, their own lighting, their own amount of detail. They're separately tracked and created. And then there's different stages. These elements change out from department to department. Starts here in story where they kind of rough sketch it, trying to figure out ideas, because it's really, really, really expensive to figure out the movie all the way at the end and then decide, I don't like that character, let's take him out. So they try to do as much in story as they can, because it's cheaper to get someone to sketch it out. Doesn't always end up that way, though. Sometimes they do decide after it's done to go back. So layout. The next sort of level up, instead of just hand drawing, they actually take digital assets and kind of stage them around and kind of get a good look. And they'll assemble the movie a lot of times in this stage just to see if it kind of all works. And then they actually make stuff move. And the animation goes through stages, kind of rough animation where it's kind of crude movement, to refined animation where they've got all these little joints and everything's really fluid and they commit all the way. And then usually the last stage is lighting, where it really comes to life. Lighting does a lot. It's fun to see a scene that was previous to lit and after lit And you can see there's a lot of light bouncing off, and they've got little digital like lighting kits where they kind of move the lights around and the cameras around, and it casts shadows and light bounces off of objects and radiates. It's really cool how that all ends up working. And that ultimately ends up here to this final scene. Quite a lot that goes on from start to finish, but we could easily go into another hour of how that works. So any given production takes about 4 hours to produce, as far as to produce, 4 hours, 4 years to produce. 4 hours, man, that'd be awesome. 4 years to produce. 90 minutes is the average animated movie. That's 130,000 individual frames. There's 24 frames a second. So you can figure for each one of those, that ends up being a lot. There's thousands of assets, as I showed you, in each frame. And then with each one of those, there's thousands of control points. And by control points, I mean, you know, each animation decision, moving the arm this way, moving a light this way, adjusting the camera this way. The camera's moving, lights are moving, actors are moving. All amounts to decisions that are trapped in files. And ultimately, there's lots and lots and lots of files. So part of a pipeline in animation is managing all of that. So in the end, DreamWorks is a digital manufacturer. Some people produce widgets of all kinds, physical things. DreamWorks produces high-resolution, really sophisticated digital assets. So in just one film, it's not just enough just to create the initial thing. Nobody's typical workstation's powerful enough to create one of those high-resolution results. So what they'll do is they'll process it on a render farm, this massive amount of CPUs that crunch away on these things. And of course, if we did it all procedurally on one workstation, it would probably take us, I don't know, 10,000 years to make the movie. So they parallelize it, they take advantage of these massive render farms. There's a bunch of process that makes sure everybody gets their fair share there and gets their stuff out. And of course, lots and lots of terabytes of the data that sits out there, lots of files, lots of pixels. That's what's going on in the end of the day. It's converting it into a single pixel. All those decisions, the lighting, and all the decisions of where the camera looks, and it ultimately changes that little 1 pixel, different colors. It's a lot of math going on to give that full resolution resulting image. So this is a cross comparison, How to Train Your Dragon 2, same story there as well. Lots of storage, lots of times to produce, a lot of render hours, and on and on and on. So to get an appreciation of where we ended up with Microservice, I'll take you from the start, before we had any of that stuff. At the start, we only did maybe one movie every couple of years. So on that, typically each show had their own pipeline. They had like pipeline, they call them TDs. These are specialists that are you know, they're scripters. They're pretty agile. Some of them were C++ engineers because they're in that space already, because all this graphical computing, that's that language in that domain. And they would have been a pipeline for that particular show. There was one actual lone Java application. It was in Swing. This was early days. I'm talking like 1.x Java. It's like 20 odd years ago. So the rumor was that Gosling actually showed up because he's really excited. This was one of the first studios actually, or companies actually attempting to use Java. So it's kind of cool. I don't know. I wasn't there. I can't say that's true or not. But if it is, it's cool. Workflows were very client heavy. There wasn't a lot of client-server stuff going on. And when there was, it's pretty rudimentary. So the result of that was it was hard to monitor. There was crazy situations where artists or these pipeline TDs would have something really nifty running on their workstation, and they'd quit. And oh my God, what happened? Movie's not going to get done. I don't know how that worked before. So not being able to tell where this stuff was running and how to stand it back up was a problem. It's also risky to make changes, and I go on and on about monoliths. I know you guys have heard that to death in this conference, but it stood true for us as well. And same thing, if the devs disappeared, no one knew how it worked anymore. Especially if it changed hands over and over and over, which tended to happen as people came and went, because the community's small. They'll go to Disney one day, they'll come back to DreamWorks, artists kind of interchange out, as well as the TDs that write these pipeline scripts. And that is a challenge of are you brave enough to make a change in something with not a lot of unit tests that's changed hands 5 or 6 times. If the show needs to get out on December 15th, you just kind of back away slowly. So, which isn't great, right? Because you want to innovate there. But that was a problem. And it's difficult to scale, because if there's one of these little things running, how do you instance more? And I can tell you how they used to do it in the old days. They would order more machines. They would do it the hard way. They'd hit it with the money hammer. And that wasn't always a fun thing for the executives. So, and then when they opened up the facility in India, that was, uh-oh, how is this going to work? Because we can't share an NFS mount all the way across the ocean. So they had to think about this after the fact. And architecting a solution like multi-site and global coherence after the fact is really, really hard. So we need to change that. Where do we go next? So ultimately, they want to do more movies because one every couple of years didn't make enough money. Let's make more. So they want to do at least 3 movies a year, which meant we got a new architecture because there's no way a couple of TDs on, I don't know, 7 constant shows churning around are gonna be able to produce something all together. They needed to have a central group, and that's where I came in with my team. They want to have one uniform, globally distributed application that could tell you where all your files were, that could tell you all the choices the artist made, that could tell you all the different kinds of detail and metadata that relates to the artists and their day in, day out jobs. So with that new architecture came adoption challenges. So you would think animation studio, like this is going to be a really open to technology kind of company. They're going to be into this. They totally weren't. Artists like, through traditional workflows, artists don't like change. And so it's really difficult to go in an environment where they're making lots of change. They're up in the ante on the technology scale. But I wasn't as sort of free. So it was a bit of a social engineering thing, and I'll go into that a little bit. We went through a little bit of an evolution of the architecture we chose. We started with SOAP, then went REST. You know, our skill sets initially were in C++, Python in this area, and then we went to Java. And then JE, and then Spring, and I'll go into the transitions a little bit here now. So when we first were told, the CTO had, he kind of was ahead of his time. He wanted us to do microservices before microservices were trendy, like we didn't even know what those even were. He's like, we should microtize these things down, because think about Linux. Linux is composed of a lot of different little running parts. It's not sort of one big monolithic system. And the value in that is that I can upgrade different aspects of Linux without having to bring the whole flipping thing over and over again forward. So we thought, all right, we're going to model it like that, and we're going to go for this SOA thing. Well, SOA, we had a vendor come in. I won't be too specific with the vendor, but I'm sure you could all guess. There's not that many of these big vendors. They're like, here's the package. It's SOAP, XML, ESB, Beeple, app servers. It was a lot for us to take on. A little quick story there. We all went to go for this SOA training at their facility. A day in, we did these little workbooks, and we were like racing through, and I'm thinking, oh my God, I'm not getting it. They all are. They're racing through these books. At the end of the day, we're all having dinner, and we're comparing notes. I'm like, all right, guys, I got to be honest. I didn't understand most of what we went through. I just kind of went through the exercises. And they're like, well, I did the same thing. I thought you got it. I was going to ask you later. None of us got it. So it took us a while after to kind of skill up in it. And we did. We got better at it. And to be honest, the Java JEE stuff wasn't making it easier. The minute we transitioned to Spring, wow, night and day different. Like all that boilerplating just went out the door, and I could concentrate on business logic. And I know they say that over and over again, but it was true. I was able to throw away half of all that stuff that I had to figure out how to do, and Spring came to the rescue there. Ultimately, we got rid of all that stuff altogether. In honesty, it really got in the way, and there's probably a lot of business cases for it even then for us, but a very agile, fast-moving, sort of more on its face kind of stuff we need to get on it. And the whole SOA, XML, and Beeple and all that stuff just didn't make sense for us. The minute we transitioned to REST and JSON, it got easier. And Spring even helped even more. So as a cross comparison, I went to a Spring class in El Segundo. It was a one-day class, same deal. Wow, beautiful. They had examples and everything I could possibly imagine, from messaging to interacting with databases. They were very opinionated. They had it all laid out in different package space. I was able to like almost cut and paste some of that stuff in and use it de facto, replacing out certain values. And it actually kind of drifts into the story of Spring Boot, which is kind of where they went with that. But it was a lifesaver. The only hang up, because with the good comes with the bad, the Spring messaging stuff was a bit of a weird one. We used Apache Cupid, for anyone that's familiar with that. It's a kind of messaging solution that uses a protocol called AMQP, and they were basically the takeaway there is to say that it'd be great to kind of have uniformity like through JMS, where you're using the same sort of APIs to talk to the different messaging brokers, but you can't have, say, a TIBCO client talking to an ActiveMQ server. Even JMS gave you the same sort of interfaces between the two. The protocol is different. So AMQP was an attempt to try to get everything to talk on the same protocol. And so we bought into that, and we went with AMQP, and I thought, Spring to the rescue. It's going to totally bail me out of this. They're going to one up it, and it actually kind of didn't. And the reason was is they went in on RabbitMQ. and they were VMware at the time, and it made me a little nervous because I'm like, is this the start of Spring kind of drifting away from the we're friends to everybody to we're more friendly to the things that are in our suite of product. So that's one thing that I've been mentioning around the conference. Like I love that Pivotal's helping to fund them because I love Spring, but I hope they don't get too involved in their own product line to the point where they become one of these monolithic companies that we fought to get away from. So only takeaway there. Transition for clients. So we don't have web UIs like a lot of companies do that the services talk in between. We've got artists applications, got lighting tools and animation tools, and these sorts of things are talking to the back-end services, but they're not exactly tailor-made to work in that. So we created library wrappers in order to sort of hide or disguise the fact that they're talking to services. So the pros was they had familiar APIs. They look like C++ or Python APIs. Sort of inspired by SOAP because that was kind of a SOAP thing, but we carried it forward with REST as well. So the cons was that we did that because likewise they didn't know they were actually invoking services. So something they'd put spinning in a loop for 10,000 times got really costly, and they didn't know. They're like, I don't know, I'm just invoking this method to get these values out. Why is that a big deal? I'm like, because you're reaching over to Texas 10,000 times. So education was big. I had to take the groups one in turn and kind of evangelize REST, which I think was the best thing that we did ever. Because once it clicked, then they understood. They actually started asking for batch kind of capabilities, and I knew they were getting it. And so I think that went a long way forward to get success for us. Is kind of cluing everyone into what we were doing instead of hiding it. So it was a foreign architecture again. The studio is kind of hostile to any foreign architecture. So a lot of social engineering. I can't stress this enough. As much as I know we're all in the business to figure out the best algorithm to get something done, if you don't have the social engineering skills, you're in trouble. Because half my day, half my week sometimes, as I moved up the chain to become more of the tech lead, is less tech leading, more social technical leading, bringing teams in together, getting them to understand what we're trying to do, working with them, trying to build things in their direction so they felt included, which made them adopt it faster and evangelize it outward to their people. So things also improved the platform QA teams. We didn't have platform teams or QA teams. I know a lot of you probably just take that for granted, like, we got ops and we've got QA. We didn't have any of that. We were our own ops and QA. When the platform team came in, now we had environments that we could deploy to and test in. We had QA team to validate that this stuff actually worked before it hit production. Old school and a lot of VFX houses today, it's Wild West. It's you throw it up there and I hope it works. And when there's deadlines, that gets scary. So it was a little bit of discipline when there wasn't any before. I give these guys street credit. It was like going in the Old West as a sheriff and kind of cleaning up the town. It was rougher on them than us. But it's paid out, and again, just like us, everyone couldn't imagine a world without them. So let's see. Microservices scale to meet multi-show demand. True, it actually worked. We would have these massive render tests. Like I said, our denial of service isn't like the outside community hitting our websites. Our denial of service attacks are the render farm all lighting up all at the same time because every show wants to get their images out that night. And I think its peak, it's 110,000 transactions per second. And that's not web traffic, that's not external traffic. That's our crazy internal render farm hammering away at our services to get the information out that they need. So optimal databases could be used per service. This was huge for us. So I know the whole microservices thing is about, being able to tease apart your databases and picking the right database for the right kind of thing. I can't emphasize that more. That's been massive for us. Because certain query performances we were getting in some of our service were dismal when they were trapped in that one big monolithic database. Because certain joins that we were trying to do to bring the data all together would not only cripple that particular service, it would cripple all the other services because it would eat that resource up and then everything else suffered. The minute we teased it apart, everything on its own could scale independently. And that's been big for us. Now, the big question that comes in, and this hit us, is if it's all teased apart in different databases, like Cassandra here, Mongo here, how do you correlate the data together? And it really forces you to think about secondary indexes. So I went to a conference, a Cassandra conference, and I had that same conversation there. I'm like, how do you guys do it? And a lot of times things like Elasticsearch were used. They would combine information from all these disparate databases into a secondary database. There's a little bit of latency, so the whole eventual consistency, everybody's got to buy into that. But once they do, you've got this amazing performing secondary index that you can reformulate in different ways. You can have multiple secondary indexes that are really good at answering specific questions. So you don't have to tease out and get every query answered by that one database with their crazy join statements. So that was, I couldn't emphasize that more. Plus smaller teams, smaller targets, agility. Gone to the days of, I don't want to touch this code because I don't know what'll break if I touch it. Everyone had their little area that they could feel flexible in and change without destroying the whole rest of the ecosystem. And I have a really small team, and we were able to move really, really fast. So I can't stress more about, I bought into the whole microservices, small teams, small deployments. It works. So what are we doing now? Spring Boot. That was another one of those. I went to an education session. Actually went to Java 1 when I first saw this, and Josh Long got up there. So I have this new thing called Spring Boot, and it looked a little foreign to me, and I was a little nervous about it. But oh my gosh, convention over configuration totally works. So all those things I was cutting and pasting and replacing values out in, gone. It just does all those things that I was having to do. So again, less code, the more powerful I've become. We typically lean on the conventions. But where are my beans? This freaked me out. This is the most scary thing. If you haven't used Spring Boot, one of the scariest things you're going to face is you're going to be looking for the config files. You're going to be looking for where these things are defined, and you won't find them anywhere. You can do like a little iterative thing where it'll list them out for you, but it's almost like you have to use it for a certain amount of time to get comfortable with the fact that they're not there, but you know they're kind of there. But first steps in there, it's a little daunting. So my favorite quote from Josh Long, make jar, not war. This is a lifesaver. We were deeply embedded with a really heavyweight JE server, and the ops guys felt really comfortable with that, but deployments were long and hard. We had these big clusters. The minute that Spring Boot came in and wired itself with its own web server, that was the final catalyst that they said, you know what, it's silly that we're doing these big, expensive app servers. Now's the time we're going to adopt Tomcat, and we're going to be happy for it. This is a scary thing for a lot of corporations, including ours, because they want to get that big bad person on the phone when something goes bad. Because the production's got to deliver, I want to make sure I get their customer support team on there. But the reality of the customer support scenario has been, for us at least, I got to go through tier 1, tier 2, tier 3, tier 4, tier 5, and even tier 6 is like, I don't know, that we bought that company a year ago, and I don't know if anyone's there anymore. So having really hungry open source developers behind your stuff, they want this stuff to work. That's been more advantageous than anything else. In this conference alone, I was dragged into rooms, and I'm like, well, who am I talking to? I have a question about Spring Data, and they're like, this is the guy that wrote it. So it's like, this is awesome. I couldn't get that with the other vendors, even though there's that comfortable feeling, supposedly, that if you buy in with a big company, they'll give you the support you need. Actuator. I love that actuator. If anyone is using Spring Boot, it's a crime not to use actuator. It produces automatically metrics. It tells you the health. It tells you all kinds of environment variables that your thing's running with. We had to custom out all that stuff. No more. I just wipe my hands clean of all that. The only problem with it is we are diverse. I'd love to say we're pure Java, Spring. That's everywhere. That's how our services are done. But it's not true. We have a lot of Python developers. And if you really buy into the whole SOA thing, and the whole, true microservices thing, it's supposed to be language agnostic. It's supposed to be platform agnostic, and we want to respect that. But the problem is, Spring Boot sets up all these great conventions. Those aren't set up equally for all these other language spaces. So if we want to create a standard for the ops teams, everybody's metrics should look like this. Everybody's info pages should be formatted like this. That's criminally hard for some of these other languages to have to copy all that. So that's been kind of a challenge. We have that now. Spring IO is great. If anybody wants to get into Spring Boot, I've lived off of Spring IO's examples. They're just like the old tutorials I took. Spring IO has every scenario covered, every database covered, every broker scenario you can think of. Awesome, awesome, awesome. Then it's like, should we move everything to Spring Boot? Because I love it. And I don't know if you guys are challenged with this, but anytime I find a new technology I love, I want to bring all of our other stuff along for the ride. And that's a challenge today. I'm still wrestling with that because it's like, do you move it? It's working, but then everything would be in the same space. So for maintenance, everyone would kind of be familiar if they have to maintain it. I struggle with this still. I don't have the right answer yet. So Spring Data, simple, maybe too simple. These different databases we're using them for different types of scenarios. Spring Data is great because it gives you a great initialization to that world, but the problem is that a lot of times you'll find yourself oversimplifying what you're trying to do because Spring Data makes it so easy. and you'll start resisting trying to do what some of these things really are good at. Because these things have to fit that Spring Data mold. There might be sacrificing a lot of what they're really good at to fit that mold. So that's been a challenge. Move everything to Spring Data. Again, I wrestle with this all the time. Spring Cloud. We're just starting to get into the cloud stuff. You know, we've dedicated to all of this infrastructure. So hypothetically, not only can we push all that computing power to the cloud when we need to render things out, we can push all kinds of storage out to the cloud, so we don't have to buy so much storage in advance. People, we could push people out there and allow them access inside, which is huge in this industry. Everyone hires up this massive army to get these things done, and it's expensive because a lot of times they're sitting around waiting for their turn in their part of the process. But what if you could push this out to them? If you've written them as microservices, they become accessible now. They become deployable out there. And that was a huge bet that we made, and we're starting to get the payoff now for that. So the Spring Cloud configuration that Spring's offering, it's helping us move in that direction. The configuration stuff was great. As an example, you know, by default I think it's Git, and I pitched that to our ops guys, and the ops guys are like, no, we don't like Git. Can you do it with console? And I looked up on Spring.io, and it goes, how do I do it with console? I'm like, yes. Yes, I can. And it was literally just like a couple of lines, and up it came. I love Spring. So, lessons learned. Generalists are awesome. I know there's the tendency to interview and get that perfect person that knows that one particular skill, but I can't stress enough. Everyone on my team, they're just good computer scientists. They're just good about figuring stuff out. And that's how I've survived, is the fact that I'm like throwing them different databases, containers, languages, frameworks, and they're okay with it. They geek out on it and they get it done. And that's been huge for us. Social engineering is huge. I can't stress that enough. Building with your consumers. And keep your vendors honest. Even Pivotal. I love Pivotal right now, but I hope they stay who they are right now. I don't want them to become one of these other big giants that tend to forget their roots and tend to just get comfortable. Don't get comfortable. Spring lessons learned. Don't fear change. When I saw XML when I was learning Spring the first time, I freaked out. I'm like, who codes in XML? But then I loved it. I'm like, I can see all my dependency injections everywhere. This is beautiful, all in one snapshot. And then they got rid of XML. And I'm like, where did my XML go? And I freaked out again. And then now I can't imagine going back to XML, honestly. The constructors alone, I'm sold. And Spring Boot is another one of those things. Where's my beans? I can't use this. No, I love this. I could never go back. Don't fear change. Don't get too comfortable. And I learned don't settle. I mean, Spring Boot, Spring Data, they're great, but they're starters. Don't feel afraid to go outside the boundaries of what they do by convention. Most of the time it works out, but when it doesn't, it lets you extend and expand. Take advantage of that. Don't settle. And leverage the experts where you can. One of the things, I'll be honest, and probably shouldn't give away my trade secrets, I look amazing there because I'm leveraging all this stuff. When all these metrics come up, when all my stuff's so monitorable and it can deploy to the cloud, I love to say that I custom built all that stuff, but I didn't. I just look good leveraging the stuff that Spring's done, and I'm gonna keep taking advantage of that as long as I can. Small team. So where are we going next? We're going cloud native. We need to explore more REST. We need to embrace the containers, and we really need to do the CI/CD thing. We're just on the forefront of doing that. But we need more rapid iteration. Some of the procedures of getting things out there has been kind of daunting. So I'm a big fan of open source. I've leveraged the heck out of it. It makes me look great. But I'm also a big fan. The reason I'm talking today is I'm a big fan of communication too, open source communication. We should talk about how we do this stuff. I know a lot of companies kind of hold it to the chest, but I really like this conference alone and other conferences I love. The eBay comes out. I want to come out too. I'm like, this is what we're doing. Let's talk. I'm in Glendale. If you guys are in the area, we actually have free lunch every day. It's kind of a perk for us. If you ever want to talk shop and compare notes, I'll get you on campus. It's a cool campus. We'll do lunch. Got to do that. It's Hollywood. And that's my email address. Feel free to contact me. I'm all about communication, so let's talk. And I think I have like 1 or 2 minutes for questions, but I can easily take them outside as well if you guys have questions. So anybody have any questions, anything?
So in your last slide, as you're talking about continuous integration, continuous delivery,
yep.
What are you, this isn't just a Pivotal Cloud Foundry question, are you looking at PaaS, are you looking at that kind of?
Yes. Yeah, partly why I'm here is, one of the exciting things about Pivotal, and of course they're probably happy about this, is the ease of Spring and all the conventional stuff. When I saw the demo on Cloud Foundry and the CF push, And there it is. Conventionally, it's in the cloud. And oh, by the way, we can deal with back pressure and all that stuff that you don't have to custom out. We are absolutely looking at that. But I remember I talked about vendor lock-in. Some of what I'm doing is I'm vetting out all the different things out there and seeing kind of how they compare. But we're absolutely interested in that. I don't want to. I'm not a big fan of invent myself, so I want to lean on the expertise of others.
How do you handle like distributed tracing?
That's a great question. So we use App Dynamics for APM. So I leverage the heck out of that. It helps trace once it gets to the service all the way down to the database, and we can do some stuff there. Our platform team has customed out a system that relays stuff to an elk stack. And so one of the challenges, because it's all these disparate pieces, is to make sure we have a correlation ID attached to all the ton of stuff that goes into the logs, so we can select against that. That goes all the way up to the artist tool. Like when a lighter makes a decision and it invokes a service, it actually sends down in that payload that traffics through the whole thing. So if they go, hey, when I hit this button, it's really slow, we can in their logs see what ID generated from that and trace it all the way through. So that's kind of where we're at with that. So I'm 1 minute past, but again, I love talking with people, so we can talk out there or at lunch or anything else, and thanks for coming.